Hi, Algebra 2. We are starting Unit 4, which is exponential functions, and this is Lesson 1. So we just finished talking about linear functions in Unit 3, and linear functions grow by equal differences for equal intervals. They had a constant slope. Exponential functions, which we're doing in Unit 4, grow by equal factors for equal intervals. So we need to fill in this top here. For some reason it didn't get printed, but I have 3 to the negative third power, 3 to the negative 2, 3 to the negative 1, 3 to the 0 in the middle, 3 to the first, 3 to the second, and 3 to the third. Okay, so you can see that 3 to the first is already done for us. 3 to the first equals 3. We have that right down here. 3 squared equals 9. 3 to the third means 3 times 3 times 3, which is basically 3 times more than the 9, which is 27. So each time we're doing this, we're multiplying by 3. Okay? 3 to the 0 is actually 1. And you can do that in your calculator to check. All right? And one time, and again, we're multiplying by 3 to get to the next exponent. 3 to the negative 1 is 1 over 3. 3 to the negative 2 is 1 over 3 squared, which is 9. And 3 to the negative 3 is 1 over 27. And again, all of these can be done in a calculator. So to go to each next number, you are multiplying by 3 each time. If I was going the opposite way, I would be dividing by 3. Right? So these are my exponents. I'm not going to do all of them. But that pattern can be duplicated for any base raised to any integer exponent. So let's look at some of these rules that I have down here, the integer exponent rules. So if I have b to the x power, that's just really 1 times b times b times b times b. However many x's I have, that's however many b's I have. So whatever that exponent is, that's how many times I'm multiplying b by itself. So the exponent represents the number of times you multiply the base by itself. Oops. Multiply the base by itself. Anytime I have a number or a letter, an exponent, to the 0 power, that equals 1. Anything to the 0 power equals 1. Doesn't matter. It could be 5 to the 0 power, that's 1. 1,000,000 to the 0 power, 100 to the 0 power, anything to the 0 power is equal to 1. And you can verify that in your calculator. Now when I have negative exponents, that means to divide by 1. Basically, you just put everything in the denominator. Put everything in the denominator and make it positive. So b to the negative x is 1 over b times b times b. Whatever x is, that's how many b's I would have. So if I have 3 to the negative 7, it's 1 over 3 to the positive 7. So that's how I take care of negative exponents. And the last rule I have here is ab to the x is a to the x, b to the x. And the same thing holds true for division. If I have a divided by b to the x, that exponent gets distributed over parentheses. This would not be true if I had addition or subtraction, but for multiplication and division, that exponent gets distributed over the parentheses. All right, we're just going to try some problems. Given the exponential function f of x equals 20 times 2 to the x, evaluate each of the following without using your calculator. Yes, I know we can put these all in the calculator, but f of 2 is going to be 20 times 2 to the second power. Now, I have to do exponents first, so 2 squared is 4, and 20 times 4 is 80. So that's a nice easy one. B has f of 0. 20 times 2 to the 0 power. Well, we just learned anything to the 0 power is 1. But that 20 is hanging out in front, so 20 times 1 is 20. And my last one, I have a negative. So I tried a positive, I tried 0, now I'm trying a negative. 20 times 2 to the negative 2. Well, I'm going to take this 2 to the negative 2, and I'm going to make it a positive exponent by making it 1 over 2 to the 2. And that would be 1 over 4, because 2 squared is 4. And again, I'm now multiplying that by the 20 that was in front, and I have 5. Okay? So there are lots of exponent properties or laws that are important, and we'll look at them through some examples that we have here. So exercise 3, they said we can write the product as a single exponential expression. If we want, write A and B as extended products first if we need to. So just to show you, 2 to the third really means, let me get my pen, 2 to the third means 2 times 2 times 2. 2 to the fourth means 2 times 2 times 2 times 2. So how many 2's do I have? I have 7. I got 3 over here, 4 over here, so it's 7 total. So I'm just going to write it as 2 to the 7th. 3 to the 5th means 3 times 3 times 3 times 3 times 3. And 3 squared means 3 times 3. How many do I have? I have 7 of them. 3 to the 7th. And 2x squared y times negative x to the third y to the 7th. You can see what's happening when I'm multiplying. I'm adding those exponents up. So 2 times negative 1 is going to be negative 2. I have 2 x's over here, and I have 3 x's over here, so that's a total of 5 x's. I have 1y, there's no exponent, that's 1y, and I have 7 y's over there, so that's y to the 8th. So when I'm multiplying, I add the exponents. All right, when I'm multiplying, I multiply any numbers that are in front, any coefficients, but I add the exponents up. All right, so exercise 4. Each of the following, write the quotient as a single exponential expression. If you want to write them as extended products first, you can. So 6 to the 4th means I have 4 6's. 6 squared means I have 2 6's. These get canceled out, and I'm left with just 6 squared. Same thing here, 2x to the 5th. I got 5 x's. 1, 2, 3, 4, 5, and on the bottom I have 3 x's. Well, I can cancel out anything that's in common, and I'm left with 2x squared. So you can see what's happening when I divide, I subtract the exponents. So same thing here, I got 15 over 25. I'm just going to reduce that to 3/5. I have 7 x's on top, I have 1 x on the bottom, so that's going to be 2 x's. And I have 3 y's on top and 1 y on the bottom, so I'm going to be left with 1 y on the bottom. So I'm going to write anything that's in the numerator, 3x squared, and anything that's in the denominator, 5y. Let's write some rules down so you have them for when we're doing some practice tomorrow. So basically, when you are multiplying with the same base, you keep the base and you add the exponents. So b to the x times b to the y, the base is the same. I add those exponents. It's b to the x plus y. B to the x divided by b to the y is b to the x minus y. So when we're dividing with the same base, this only works if it's the same base. You keep the base and subtract the exponents. Okay, so let's try some. Each of the following, write the exponential expression in the form 3 to the x. Write A and B as extended products first if necessary. So 3 squared really means I'm doing 3 squared to the third means I'm doing 3 squared 3 times. 3 squared to the third. 3 squared is going on 3 times. Now when I'm multiplying, I keep the base and I add those exponents. 2 plus 2 plus 2 is 3 to the 6. 2x to the negative 2 to the third power really means I have 2x to the negative 2, and I'm doing that 3 times. I'm taking that whole thing and doing it to the third power. 2 times 2 times 2 is 8. And x to the negative 2, I'm adding those exponents. Negative 2 plus negative 2 plus negative 2 is negative 6. So we can see what's happening when I have a power to a power. I am just multiplying those. Power to a power. I am just multiplying those. Okay? So this whole thing is squared. So basically I'm taking negative 4, x to the third, y to the fourth, and I'm multiplying it by itself twice. So negative 4 times negative 4 is positive 16. X to the third times x to the third is x to the sixth, because I am multiplying, I add the exponents. And y to the fourth times y to the fourth is y to the eighth. But if you can see what happened here, this 4 was multiplied by the 2, or power to a power. I multiplied it and I got y to the eighth. This 3 is multiplied by 2 and I got x to the sixth. All right, so when I have a power to a power, you are multiplying the exponents. A power raised to another power, multiply the exponents. So this is stuff that you've certainly seen before. All right, we'll do a little practice with exponents on the next page. So here I have 3x to the 0 plus 3x squared. What's the value of f of 3? So I'm plugging in 3 wherever there's an x. 3 times 3 to the 0 plus 3 times 3 squared. So anything to the 0 power is 1. So this is 1. I have to multiply 3 times 3 before I do it to the second power. So that's in parentheses. 3 times 3 is 9. So now I have 9 squared is 81, and 3 times 1 is 3, so that's 84. All of these can be done in a calculator, but I do want you practicing without a calculator just to make sure you understand these rules, but you can always double check in a calculator. So 2/3 to the third power, everything's to the third power. 2 is to the third power, and 3 is to the third power. 2 to the third power is 2 times 2 times 2, which is 8. 3 to the third power is 3 times 3 times 3, which is 27. Now this 1/3 to the negative third power, remember to make that a positive exponent, I'm going to do 1 over 1/3 to the positive third. To make that negative exponent positive, I put it in the denominator. I put everything under 1. Well, that's really 1 over 27, because 1/3 to the third power means 1/3 times 1/3 times 1/3. Now 1 divided by 1 over 27 is just 27. So I really have 8 over 27 times 27 over 1. These cancel and I'm left with 8. So that was a little bit trickier. Because this is 1, let me just show you in a different color. 1 divided by 1 over 27. And when I have division, I change to multiplication and I flip that fraction. So that's how that became 27. All right, simplify the next expression. 2 over 4, I can just reduce that to make that 1/2. Okay. X to the negative 2, in order to make that negative exponent positive, I'm going to put it in the denominator down here. And now look at the y's. I have y to the negative 2 and y to the negative 5. When I'm dividing, I subtract exponents. So negative 2 minus negative 5. I'm dividing, so I'm subtracting the exponents. Negative 2 minus negative 5 is actually 3. So I'm left with y to the third. Since it's y to the positive 3, that goes in the numerator. 2a to the negative 4. To make anything a positive exponent, I put it in the denominator. That's 2a to the fourth. Now that 2a was in parentheses, so everything is to the fourth power. The 2 is to the fourth power. 2 times 2 times 2 times 2 is 16, and the a is to the fourth power. So that's my answer. Okay, we're going to work with some more of these tomorrow on 5, but just to give you an idea of how we're doing this, I think these you can see in your head. Tomorrow we won't necessarily be able to see them in our head, what to do. 3 to what power equals 27? Well, 3 to the third power equals 27, so n equals 3. These we can just see. The ones tomorrow we won't necessarily be able to see. 6 to what power equals 1 over 36? Well, it's a fraction, so it must have been a negative exponent. And how am I getting 36? Well, 6 times 6 is 36, so n must have been negative 2. Okay, so this would be this, which was that. So n is negative 2. So this is leading up to stuff that we're going to do in class tomorrow to practice. And 8 to what power equals 1? 8 to the 0 power equals 1, so n equals 0.